Hello, my friends. This is Clover, and the first thing you've probably noticed today is that my video looks a little bit different from normal. I am actually in a completely different country than I was 3 days ago when you last heard from me, so pardon the mess around here while I get things sorted out. Second of all, if you haven't seen it already, Philip has just released an absolutely fascinating video about some of the technicalities of why we know that 17 givens are the smallest possible number of givens in a classic Sudoku, and some of the consequences of that. That's on this channel. Check it out. It's under Sudoku Nerd Snipes, and I'm hoping that that is the first of what will be a very long series. I found that really interesting and informative, so if you want to know more about the math behind Sudoku, check that out. Philip does a really good job making it accessible. And we are going to be solving Philip's puzzle that he released on the same day he dropped that video. This was released on March 9th, 2024. It's called a Classish Snipe. Snipe because his video discusses what he refers to as nerd snipes, a term that he explains at the beginning of that video, so check that out. And class-ish because, as you will see in a moment, even though this looks like a Thermo Sudoku, this is actually a very nicely crafted and somewhat cheeky classic Sudoku. So, Thermo Sudoku rules. Well, first of all, normal Sudoku rules apply, so we're placing the digits 1 through 9 once each in each row, each column, and each heavily outlined 3x3 region. Thermo Sudoku rules say that we have these thermometers in the grid, and digits along each thermometer have to increase starting from the round end and moving towards the tip of the thermometer. Now, the thing is, this is just Philip being a little bit silly, because he explains again in his video why this puzzle is designed like this. But this is Philip being a little bit silly and kind of disguising a classic Sudoku, because since these thermometers are all 9 cells in length, we can open our solve by just writing in the digits 1 through 9 in order along each of the thermometers. And after this point, Thermo rules are no longer going to be relevant. We are solving a classic Sudoku in the conventional fashion. So we have this box in the middle where we only have 2 missing digits, so those are going to be 1 and 9. And then the next thing I would like to look at is the top and bottom center regions, because there's going to be some magic going on here. So we have 2 4s here and a 4 here in region 9 that look into this bottom center region. That places a 4 here, that's the only possible location for it. And we have 2 6s here and a 6 in region 1 that look into this top center region. And so 6 is eliminated from all of those positions, so that's a 6. Now what we still have to place in this column, that's going to be 1, 2, and 7. Because there's already a 7 in this region, we can't put the 7 there, so that's a 1, 2 pair, and there's my 7. Here I need a 3, 8, and 9. Can't place the 3 in either of those cells, so it'll go here. And then I'm going to place an 8, 9 pair. Now my last 2 digits in here have to be 1 and 2. They'll go like that, thanks to this 1. My last 2 digits in this region are 8 and 9. They'll go in that order, thanks to this 9 here. Now let's look at these left and right central regions. So what do we have here? I have 2 2s, so I know I need to place a 2 into one of those cells. I have 2 8s, so I know that I need to place an 8 into one of those cells. And I don't have anything else that is duplicated, so I'm going to have to hang on to that for the time being and see if I can get some progress elsewhere before I do anything else. There we go. Okay, so where to next? Let's look at some of these corner regions. So these 2 1s see most of this top left region, and with the help of this one, we have a hidden 1 in region 1. And similarly, we have a hidden 9 in region 9, with these 2 9s seeing most of it, and then this 9 finishing things up. That fills in nearly the entirety of rows 3 and 7, so let's go ahead and pencil in the rest of those. And we're going to see that we actually get a naked 5 in row 3, column 3, and another naked 5 in row 7, column 7. And the way we're going to find that is observe that we still need 5, 6, 8, and 9 in this row. This cell can't be 6, 8, or 9, so that's got to be my 5. And then I'll pencil in 6, 8, and 9 here and just clean up by removing that 9. Similarly, here I need 1, 2, 4, and 5, and this cell cannot be 1, 2, or 4, so that'll be my 5, and then these will be 1, 2, and 4 in some configuration. So now, where to? Can we do a little bit more with the corners? Let's see. So we need to place 8 and 9 into region 1, and we have both 8 and 9 represented already in columns 2 and 3, and that gives us an 8-9 pair here. That is an example of a hidden pair, and the way you know that you might be looking at one of those is if you see two pairs of duplicated digits sharing a row or sharing a column and kind of looking into a region. That's how you would spot something like that. And that leaves us only needing 2, 3, and 4 in these cells, and this cannot be 4. Now the thing to note here, this is probably the cheekiest moment of this solve, is that we have these two 9s here which look into region 3 and tell us 9 goes in one of those cells, and critically 9 doesn't go in either of these cells. But we need to put a 9 in the row, and so that straightens out which way around our 8 and 9 go, because the 9 in the row can only go in that position. Because that tells us this is an 8, that gives us the 6 and 9 in those positions. So now we need 3, 4, and 8 here. That can't be a 4. And I don't think that this is necessary to the solve, but I thought this was really charming when I was first solving this one, so I'm going to go ahead and tell you guys about it. So I have 8s here or here, and 8s here or here. This looks like an X-Wing. You're free to call it an X-Wing. Technically it isn't, but it behaves more or less like an X-Wing, where we have 8s in these two cells. And what that does is prevents us from placing 8 in any of these cells, and it means that we have a hidden 8 in column 8, because it also can't go there, so it has to go at the very bottom of the column right there. So now we're going to do a whole bunch of symmetrical deductions that are going to follow up on what we just did. So we have a 1-2 pair, very similar to the 8-9 pair we had over here. So that'll be a 1-2 pair, and then these two digits are going to be 6 and 7. And we're going to take that and observe the same thing that we did with the 9s. We're going to say, okay, we can't have a 1 in those cells. We need to place a 1 in row 8, so it can only go there. And that's going to configure our 1s and 2s. That gives us a 4 and a 1 here. And these are going to be 2, 6, and 7. And so now we observe that we have 2s there, which tells us 2 has to be in one of those two cells in column 2. So it can only go there. So that's the equivalent of that deduction. Now if we look at the rest of this column, we need 3, 4, 5, and 6, and we can't totally resolve that yet, so we're just going to leave that to sit for a moment. This can't be a 6, and in this column we need 4, 5, 6, and 7. That can't be a 5, that can't be a 4. So what's our next move here going to be? So we need 2, 3, 4, and 7 in this column. This has to be either 3 or 7. This can't be 3 or 4, so this is 2 or 7. So now we have actually a 2-7 pair in column 3. That tells us 2 and 7 are in these cells, so they can't go here. So that is not a 7, it's a 3. And that resolves the 3 and the 4, which resolves a few things over here as well while we're here. So that's 5 or 7 because there's a 6 in the region, and these are 3, 5, 7. This is either 3, 6, or 7 to finish the column, and 6 and 7 are already in this row. So that's 3, and then according to our pencil marking, we have to place an 8 in one of those cells, so it must be there. We're going to use that 3 to resolve this. And we can resolve the rest of this column by following up our pencil marks. We need to place a 5 and 7 in this region, so they'll go there. We need to place 2 and 7 here. We can't tell which way around they go yet. These are going to be 3 and 6, and the 3 we have up here tells us that's a 3, that's a 6. This is going to be 4 and 5, and we have a 4 right below this pencil mark, so that goes like this. And we can't place a 3 or a 6 here. There's 3 and 6 in the row. So that's going to be a 5. Oh, and also is the last digit in its column. Good job, Clover. That's going to be a 7, 2, 6, 2, and 7. And that's how you solve Philip Newman's Classish Snipe. Now go check out Philip's video. I hope you enjoy it. Leave a comment if there's more that you want him to do in the future. And I will see you next time.